Alright, so basically I want to integrate my project box to be able to control my lights. Now the only problem with that is the code to do that, the API you have to deal with and all the extra code. I don't really want to deal with all that because I heard it's kind of buggy. They're changing security properties on the Hue hub. So before I fall down a rabbit hole with that, I'm just going to do something a little bit more simpler. I'm actually going to take a Phillips Hue switch that you can buy with a bulb for around 25 bucks or so, maybe 30 bucks. I'm going to actually take it apart and actually use the circuit board inside. It already has the Zigbee board with the Atmel microcontroller built on it, so everything is all set. All I have to do is take the board out and control the on, the brightness, the dimmer, and the off button into the microcontroller. I've already taken the board out of the case, so this is just basically an empty shell. So let's get that out of here because we don't really need that or care about that. And let's take a look at the actual circuit board that's inside. Now there is a Atmel IC on this, and of course there's no schematic online for this, so it's a little bit tough to figure out what everything does and what everything goes to. So I've already went through and probed all these switches, these little miniature tactile type switches, and I found that a couple of them are connected together and then another couple are connected together, and then they're doing some really strange things here, to the point where I can't just send a signal from my microcontroller into this microcontroller without feeling very good that I'm not going to damage anything. So the way around this is I'm going to actually hook up a set of relays. So basically what I'm going to have coming out of the microcontroller is going to be these, let's see if I can zoom up, these 4.5 volt DC relays, and I have 4 of them. So basically what I'm going to do is control these 4 relays from the microcontroller, the Arduino Mega. I'm going to put a diode across the coils because these don't have built-in diodes across the coils for surge. So I'm going to do that. So I'm going to have 4 outputs controlling these relays, which will have the 2 contacts will control each switch. It'll make it a little bit easier. It's not ideal. It might take up a little extra room, but I think it's the safest bet to do without actually frying anything, because we don't have a schematic for this board and I don't feel like reverse engineering it. Alright, so I guess the next problem is going to be, how are we actually going to power this and how are we actually going to mount this? See, there was a cell, one of those button cell batteries powering this. It is a 3 volt Panasonic CR2450. What I'm thinking of doing is, because this thing draws such a low current, I think I'm going to build a voltage divider off of the Arduino and just power it via that. That's not written in stone. I think this thing draws like 20 milliamps, so I mean, I believe a voltage divider should be sufficient enough to get 5 volts down to 3 volts to power this thing, no problem. Because it's only got to, it's only doing something very, very simple. Now the next question is, how do I mount this and how do I get all my pins to where I want to go and all that fun stuff? Well, I had an idea. What I'm thinking I'm going to do is I'm going to actually solder a header onto this board and then glue it down and then solder to the pins that go to the switches. See if I can find a... So I'll basically just glue this down and I'll actually take, that pin here and go to here and here to another pin and so on and so forth with all the switches. And that will all lay out on a header. So I'll actually have a female header on my main circuit board, so this thing will plug vertically down onto the board. Now the next question is, how do I get power to it? Okay, well, same thing. I think I'm just going to tack off the test points here. There's a few test points on each side of this board. I think the test bed where they test this at the factory. I'm going to solder, I believe, let me see if I can find, I think it's ground and power is right here. So all I have to do is feed that 3 volts along onto the header. I'll just solder a couple wires to those points, and I think I should be good. I think I should have power going in through this header and actually all the switch controls. The relays themselves are probably going to be mounted on the circuit board, and those are going to control that header row. So that is the plan, and we'll see how it works out. Alright, so my plan changed a little bit. I decided to mount the relays on the board because it'd just be easier to wire, and I won't have so much going on the main board. Everything will be self-contained. The only thing I'll have to do is actually connect some diodes across the 2 coil pins. I may do SMD, I may just do regular size diodes. I'm not entirely sure yet. But basically what I did was I took the relays and I put some double-sided sticky tape foam underneath on the circuit board, because I didn't want to glue these directly to the circuit board in case I have to replace these. I didn't want to risk pulling up vias or any kind of circuitry that there's no parts underneath them, but there are traces, and I didn't want to risk if I have to do some maintenance on this board, I didn't want to risk damaging the board, peeling the glue off. I did glue the edges on the other side to the board, which is not going to hurt anything. So that's just going to keep it a little bit more stable in case the tape decides to give way, and it will still hold them in place, which I don't think this is going to happen because this tape is pretty good. And here's the header row that I have soldered on, well, not soldered, glued onto the board here. I've cut the pins where I'm not going to be using, where it is glued, and these are all the pins here that are going to receive wires, or at least some of them. There may be some spares, and then I have another set glued down here. So this is pretty stable. I may throw a dab of glue on the other side here, where that connects there, and just to stabilize this, which it wouldn't be a bad idea. But I just want to get this thing wired up and tested, but I'm going to glue those points right there, and this should be a pretty solid, nice little module to just plug into the board. I'll put a picture up of it, what it looks like, and because this microscope cannot zoom back far enough to demonstrate the overview, so I will just put a picture up. Alright, so yeah, I'll once I start getting things wired up here, we'll come back and see how we're making out. Alright, so I'm going to show you guys how I'm hooking this up here. I actually have the freewheeling diodes hooked up to the coils of the relays. So that's how that's going to work, and I'm actually going to connect the the contacts from the relay to each switch. The way these switches work, there are 4 pads. This pad is connected to this pad. This pad is connected to this pad. Well, let's see if you can see that. And they connect across this way. So that is the same exact lead. And how that works is when you press the switch down, it connects this side to this side. So whenever you see a switch with 4 leads, it doesn't mean there's 4 contacts or anything like that. That just means that there is a connection from one side to the other, and when you press the button, it shorts it across. So when we connect our relay up here, we're connecting the output of the contact of the relay across those 2 pads, and that's how we're getting away with doing this little hack here for this project. So the Arduino is going to fire the coil. We're going to have a common negative across all these coils, and then we're just going to have each one of the outputs connected to four outputs connected to each side of one side of the relay, and we can just program our Arduino to do what we want to do. So I'm just going to do one solder job here for you guys. I've already done one just to show you what it looks like. And I'm going to show you how I do this. This is pretty simple. What I like to do is put a little flux on these before. Well, actually, let's tin them up first. They already are tinned, but from the pull, but let's get some of that old crap off of there a little bit. So they're kind of tinned now. And I like to put a little flux on there, so when we put our wire on, it makes a nice connection. It doesn't look all stringy and cold. So I have my wire that I've connected here. This is 30 gauge wire. And I like to tin the wire prior to connecting the two together. Okay, so now what I do is I hold it in a position where it's convenient for me to solder. Let's get the right relay. And we'll see if we can focus up a little bit here. That seems like a good spot. And I just place the wire right over the pin and heat. And that's it. Makes a real nice connection. And what I've been doing is I've been just bending the wire over to where I want to go. For instance, that is the position I want to be. And then I tuck the wire up. Let's get a little focus here down. Okay. And so that is where I want to cut the wire, right about there. Give that a little bit of slack. So I have very sharp X-Lite cutters. These are, I believe they're 170D cutters. They don't actually say on them, but I thought they were 170Ds. Anyway, get a good mark and just cut the wire. And then I have these Imperial wire cutters that will actually strip down to 30 gauge. Very, very, very small hole here. You can try using these side cutters to strip it, but sometimes you end up nipping it off, so I just end up using the wire strippers. Some people just burn it off, but I want a little bit cleaner job than that. Now, when you strip it, you can pretty much pull in the same direction. Just don't pull sideways when you're stripping this, because I mean, if you're using a nice pair of sharp wire strippers, it won't yank the wire. It should just cut the insulation and pull off to some extent. So let's see if we can focus up here. Alright, now since this is real short, we're just going to take a little bit off. There we go. And you're left with a nice wire to tin. Let's clean that soldering iron up. All right. So now we want to go to this switch pad here. These are really ugly because they're factory soldered with real lead-free crap. So we're just going to put a little bit of flux on there And we're going to just flow some regular solder in just to get it. Get some nice fresh solder on there so the wire will stick really nice. I'll put some fresh flux on these pads again. I'm just going to show you one wire here, but I think you get the point at this. So I'm just going to bend the wire into position. You may have to use a pair of tweezers. I like to rotate the board and pull down with my right hand and then fuse them together with the soldering iron. See if I can get this without blocking the shot. And that's it. Don't use use as less heat as you can to make the joint. As long as it's a good solid connection. Unnecessary heat will just start melting shit. So yeah, so I'm just going to keep going along like this, and just all the way down the line. Then I'm going to have to connect everything down to this header row. And yeah, we'll be back, see how this works out. Alright, so here is the final board after the Arduino modification. Let's see if we can get a little bit of light going here. It's got the header row for all the inputs and outputs, and they're all tied into the relays. You've got the flyback resistors on the coils. I even scabbed on a 5 volt to 3 volt 3.3 volt regulator here. It's a BA033. So everything is all built onto one board here. We're all set to go. So now this will set right into a single header socket on my project, and I'll be able to write code for it. So let's hook it up to 5 volts and see what happens. So right now I have the pins right here. The last 3 pins are the power pins. So I'm hoping that this will turn on. Hey, we got lights. See if the button still works. Oh, I'm holding the antenna. Yep, there we go. I got a green light. Excellent. So she's working. So now all I have to do is just integrate this into my breadboard. Alright, so now that the board is complete, and I'm just showing you here how it's all completed here. I showed you that I put a regulator on here, a 3.3 volt regulator. It is 0.3 volts higher than the battery was supplying to this, but I don't think the Hue dimmer switch gives a shit if it's 0.3 volts higher or not. So, like I said, this has its own Atmel microcontroller built on here, but obviously we can't really mess too much with this because we don't know how it's wired or programmed. So, like I said, we put all the 4 relays that are controlling each switch with the corresponding flyback diodes for surge, so we do not fry our own microcontroller on high voltage feedback from these relays when they energize. So, like I said, I put this on a header, and in my project board here, I actually have a female header ready to accept this. And what we have here is the 4 channels coming up into the microcontroller. These are digital outputs, and I have a power wire, and the ground is actually run underneath on a bus of grounds. So what we're looking to do here is, I tried to keep this tucked over in the, farthest part away from everything, because I'm going to be obviously building other circuits around here, and I want to leave a lot of room. And it'd be nice if I actually, I'm thinking that if I build an audio amplifier like this here, I'm gonna portabilize this and well, build it on a circuit board, and have probably a very similar thing here. Everything would be on kind of like boards, almost like a computer. Just just adding modules. So if you ever have to change anything or take it out or want to modify or maintain anything, it's just a matter of unplugging things from what you got going on. So. But alright, here we go. So we're just going to plug this in here, and we're good there. Alright, so now it is part of the microcontroller. I've already programmed 4 digital outputs to control these relays. So we're going to power it on and see how this functions. Alright, so now that we have the demo module installed on the Arduino here, I've already written some basic code for turning on these relays and interfacing with my project. I have a Hue light bulb sitting here on the desk for a test to see if it works. There is no connection, physical connection between this box and the Hue light bulb. This is all over the Wi-Fi. So we just have 110 volts powering the light bulb right now, waiting for a signal to be received. So let's go to the project here. Let's go to the menu, Hue Lights.
Hue Lights.
Alright, now we're going to press the button number 2 to turn the lights on, and see what happens.
Lights on. Lights off. Lights on. Light dimmer. Light dimmer. Light dimmer. Light striker. Light striker. Light striker. Lights off.
Alright, so it seems to be working via the keypad control. So now let's try it by voice command. Computer, lights on.
Lights on.
Computer, lights dimmer.
Lights dimmer.
Computer, lights brighter.
Light striker.
Computer, lights off.
Lights on.
Yeah, I might have to change lights on and lights off because they sound very close to the computer. Let's try this again. Lights off.
Lights off.
Okay, so it responded that time. So I might have to change the phrase for that, but it is functioning. That's just a little bit of a code change, and I might have to change the way, because lights on and lights off are a little bit confusing to the control board. But this thing's, every time you say computer, it just wants to go.
Main menu, select a function.
So yeah, so now that works great. I'll just turn it back on again by pressing number 2. Go to
Hue lights. Lights on. Lights off.
Alright, so that's it. That's how you can actually take a Hue light dimmer switch module and take it apart and modify the circuit board to integrate with your your microcontroller project. It takes a little bit of, like I said, it takes a little bit of time to build this board. It was a lot of work, but it was well worth it in the end. And now we can, pretty much control the lights in my house by just dictating commands or using the keypad. But I'm very happy on the way this came out, and there's probably other modules that I'm going to be integrating. I have received my infrared sensors, so we'll be integrating probably some infrared stuff too. So I hope you enjoyed the video, and well, if you like, click the like button, and if you really want to come back, and if you want updates on videos, subscribe, and we'll see you in the next one. Have a good night.